This you call to the protected zone. This is the basic functional traditional way how we protect it. That means all the bad things of DC are true. It's archive, it's arcing, high currents, complex, low selectivity, everything you can think about why you want to have AC. So this area, that's why we embrace it and we motivate the installation, the installation guys to be high numbered as possible. Because the higher the number come, the lower the risk will be and the better the functionality will be. So from zone 1, we have, for example, zone 2. And zone 2 means current sources. So in DC you have, like example, PV panels. If you put the fuse in series as a panel and you try to break the fuse, nothing happens. The current stays running, but the fuse stays in. So you need a different way of protecting. That probably can be a static switch, could be a hybrid switch, that in the case when the voltage goes down, it disconnects. So this is a different way of protection. It asks also different skills for installers to define.
Maybe short circuit
So there's all these things. So this is why we call it zone 2. And here we have, for example, zone 3. And here are bidirectional electronic sources. So we have here a battery, zone 0. We have the converter. We have the solid state protective device. And we have here distributed or combined in a panel or distributed sources. That means here you need, that's why it's the Dutch flag. And the standardization, we have a lot of fun about it with next sounds. Because everybody says, no, it's the French flag, it's the UK flag. And everybody is happy. And then we talk about the safety wire, and then everybody was agreeing it should be orange. So I said, see you will see, it's the Dutch flag. This is So this is the safety wire, and in the safety wire, you disconnect all the sources. That's why this is a zone 3 cable. And in zone 4, we have here in simple final circuits with only loads, so there's only one source. But here we have all the protections you can think about. That means to make risk here, because it's simple, one source, it's full electronic protected. It has RCD functionalities, it has whatever you can think about. And that's why we have this, for example, this antenna wire, also to make sure that you can make detection of the zero arcs, because that's a hard one. So to make this installation safe. And we pushing a little bit with the insurance companies also to make a fee for the building for the insurance. Zone 4, maybe you get some money because it's safe. And when you if your part of the installation is bigger in zone 1, you have a big part of zone 1, or you have a huge part of zone 0 in the building, that means these are high risk classified. That means you could have fire risk, you could have a lot of damage. And that is why they love it, the Dutch insurance companies, because it's a good way to identify where are the risks in electrical installation. That's why it's actually genderless from this point of view. But we came up with this concept also in the Dutch standards, and the reason why was that it was so much easier to discuss what type of animal you have to discuss. Right? If you talk about the battery, if you talk about the solar panel, or you talk about the converter, they clearly classified where they are. If you talk about solid state protection, and if you don't define this proper, then these devices are everywhere, and then nobody knows what is the characteristics of the system. So this is, and therefore we make a table from all the requirements, and that is now we have the big debate in Joint Work Group 44 to get these requirements, how to say, in a very conservative, strict way, to add safety to the DC installation, because DC is a very dangerous voltage, and particularly in DC, you want to call it the high voltage. People have the possibility with converters, they want to go high as possible. Of course, you can easily go to 1500 volts, so why not? From the electronic point of view, and that's what we defined. So we defined a kind of structure and this is the new proposal. So we want to have the zone number and we want to have the X. It means the maximum voltage that could appear in the system. So it's not the nominal voltage, it's the maximum voltages. So for example, you want to classify this zone 4 up to 400 volt as absolute maximum value that the installation could be. And for example, this is 800 volt or this 800 volt in bigger systems. And then it's completely classified, and it could even be used for the self, like for batteries. You could have 60 volt, but that means this is classified as zone 0, but in a self voltage level, to make it clear on the labeling. So if you're opening a cabinet, you see the label, you know what kind of enemy you are facing. That's the point. And if you see in zone 3, that means, okay, I see a switch. Not necessarily means that if you turn off the switch, that the installation is done. Because in another building, or in another part of the building, there could be another source powering the cable. That is the point, because you have distributed sources. So a little bit.
Yeah, it's a bit more clear.
And we define it in that way to really get clear the discussions on the topics, and to have a place, for example, like the diodes, to place diodes, because in this area you can use the diodes as a system reference conductor. This area you need to have the system reference conductor as a solid conductor.
And this could also simplify our certification issues, because where we have, I would say, differences or things that the standard is irrelevant is for zone 3 and 4. For 1, more or less we comply. Well, we know we have to.
When we are talking about certification, we are talking about certification of products, not of the installation.
In the end of the day, both. And the point is, that's one of the things that is the big challenge now. And maybe to explain a little bit how we did now the buildings, how we did the projects. We did it on the Dutch way. That means we have a very high factor of tolerance, and we have in the past we have a green deal with the government, and we get an I'd say not a license to kill, but we get the government has literally said. We get literally the government have said, okay, Harry, you can go again, you can do what you want. On DC, I trust you that you do your best to make it safe. And if something happens, it was just AC. We see it through the figures. That's the Dutch expression. We don't, the same as the drugs policy, all the things, it's not allowed, but we support it. And so we get this status. And during this status, we developed the Dutch NPR 1990, where we start writing down the zoning structure. We start specifying that you need electronic protection. We start specifying the primarily incredibly conservative RCD curve, together with Biekemeyer Foundation. So without the discussion from the research that is done now, but we have a preliminary set, and Michael Koch and the people from the Biekemeyer Foundation says, okay, Harry, these ratings values are incredibly conservative, this is safe. And we start the research to see where is the limit when things become not safe. So now probably in MT4 there will be a new standard coming from Direct Touch that is less conservative than our structure. But I said, okay, if we can build an RCD in a very conservative way, because of this high defined behavior of the system, and because of the earthing arrangement, you can have very trigger happy RCDs. So we could use, for example, 2.5 milliseconds, 3 milliseconds, or 4 milliseconds disconnecting time in a few milliseconds, and to disconnect on different curves. And if it's 20 milliamps, 30 milliamps, you can put every level you want. And this is, I think, and so in this zone we have still specified on the moment, and that will be probably changed now by the IEC, but we specified 2.5 milliseconds disconnect, and we allow up to 0.1 second if the current is below 30 milliamps. And after that we disconnect. And we even, like for streetlights, could even put it to 10 milliamps. So that means if somebody is there to touch, and it's not his last day anymore, and but we are on the conservative side. And that's how we manage to get these specifications that doesn't exist in the IEC, to get in the Dutch standards. And therefore we get instead of a license to kill, we get a license to operate. So we get the possibility to have the ABN building, the Pulse building, the street lights, start building these installations without product standards, but with installation rules. And then we have inspectors that want to inspect the installation, against which standard, they don't know. But then I said to them, listen, they write the standards to explain how you not kill people. That's why the standards are written. So please, we invite the inspector into the lab. I said to the inspector, please ask all the questions you want to do all the tests you try to do, to understand what is the behavior of the equipment. And if you feel comfortable, we go to the public side, and there you can do your test to see if the installation is under all the circumstances reacting as you expect to consider it as a safe installation. So don't look to standards. And then they one company get a project from the municipality where they ask the municipality asking to the inspector, is DC as safe as AC? And the funny thing was that they make in the streetlights connection faults. So one of the poles was not earth connected, and they find it. And so we got a problem, and they tried to make earth fault conditions, and it was all the time reacting. So we even with earth above 1 kilo ohm, 2 kilo ohm earth impedance, we could still protect it as in a protected measurement inside the timing. So then they really said, okay, we have an installation of 3.5 kilometer with RCD functionality, even with not proper connected PE, we still have reaction. So for us, the answer to the municipality was no, DC is not as safe as AC, DC is safer. Because it fulfills all the protective measurements, what was not feasible by AC.
Well, not feasible with electromechanical protection system.
No, but also not the RCDs are not feasible, because if you have 3.5 kilometer cable, you have so much currents from capacitance, so you cannot detect anymore.
Yeah, but if you start to split earth and so on, you will also solve the capacity payment issue probably. So. But
that is the point. So that's how we manage it in the Netherlands, of course, and that works in the Netherlands. That is with Dutch guys. We are a little bit more flexible. In Germany, it will never not work like that. I think in France, it's also quite a headache to get this done. Maybe Greece, it will happen again. But that is how we did it. And that's why we get the lessons learned, and that's why we can progress with the knowledge we have and the experiences we have. And so all the installation concepts like we have here are built up from the concept of the thinking, from implementation and doing, and get the lessons learned and validate it's working to move forward. So it's not a paper acquisition. It's not cheapware, it's really hardware, and it's there.
Yeah.